Bonjour and good morning. Welcome to WASA Distance Education Center and PLAR Science. We're into week 5 of term 1B. So that means that after this week, we only have one more week left and then we will be off for our Christmas break. Let me just fix the pen here. So today is Monday, December 9th, and then we will be done on our last day of work is Friday, December 20th. So we have, after this class, 3 more classes left. All students are welcome to join the radio Zoom classes. So if you're wanting to participate, make sure that you go to the front page of my lessons or the study guide and you will see the link for the radio Zoom class. Students who wish to register still for independent learning courses, you can do so at any time during the school year. You just have to complete the course on or before June 13th, 2025. You can contact your local distance education coordinator. You can contact Mary, she's responsible for PLAR, or you can contact Michelle if you're a non-PLAR student. You can also sign up by using our online application form. If you need a hard copy, you can contact our DEC or one of the counselors. We may be able to fax one for you or just send you an email. Looking at the course calendar for PLAR Science, you can see that it is week 5 and we're right on track to starting lesson 3, which is chemistry. So if you are following along, make sure you have your lesson 3 lessons. Also, WASA will continue to hold 2 student draws. So we have one for students who earn a credit. So if you completed the PLAR Science and you were successful in getting the equivalent credit, then you will have your name for that draw. And also for submitting it. So you can get 2 for submitting your work and earning a credit. Students working on multiple courses, so if you're working on the PLAR Science, PLAR Math, PLAR History, PLAR Geography, then you will get your names entered for each of those subjects. To contact me or any of your teachers, you can call the office at 1-800-667-3703. We also have, that's the toll-free number. For my extension, it's 2204. We also have a toll-free fax number. You can email me. You can send me a message through Messenger regarding any of the PLAR questions that you may have on J. Mercer WASA. Office hours, this is available. You just have to ask for it. And you may also call me at home. Options to submit your key questions. You can have your DEC fax your work. You can have it scanned and emailed to studentwork@nnec.on.ca. Make sure that you are CCing the teacher that's marking your work. Also use your Notes app to scan email your completed key questions or culminating. You can send a picture through Messenger or you can drop it off at our WASA office or outdoor mailbox on the side entrance. Those of you doing the lessons, you can submit your work as you complete them and make sure you're contacting your teacher if you're needing help. Remember that PLAR Science, PLAR History, Geography, and PLAR English and Math. So all the PLAR, they're all on YouTube. Actually, all the classes now for term 1A and 1B classes are all on the WASA Distance Education Center YouTube. So broadcasted lessons can be accessed in this site. Make sure you click the subscribe button. That way you will get a notification whenever a new video has been uploaded. So you can see here we have the PLAR Science, the PLAR Math, the NBV 3E, which is the Worldviews and Aspirations of First Nations, the Grade 12 English workplaces there, the co-op, which is the DCO 3O, The PLAR Geography from last term is there, same as the PLAR English, PLAR History, the Grade 12 College English, the MAP 4C, which is the Foundations for College Math, and the OLC, or Ontario Literacy course. For those students requiring the Ontario Literacy course, and if you're working on your IL courses, you can still check out this site, which will have the full playlist of the Ontario Literacy course. Okay, you don't have to be in the Radio Zoom class in order to view these classes. These are for all students. So PLAR students have the option of either completing the key questions from the lessons, or you can choose to take the culminating activity for that PLAR subject that you're needing. So it's up to you to choose the option that works best for you. Remember, the key questions will help you review important concepts and prepare for the culminating. On the other hand, the culminating will assess your overall understanding of the material covered in the course, so you can challenge it. Once you have decided, so if you decided that you will like the culminating activity, then we can email that to the DEC or to you. Remember, supervision is not required. You can actually take the culminating activity home to complete. Successful students, so students getting 50% and above, will receive their equivalent credits, and then you can proceed to sign up for your senior PLAR and senior credits. If for some reason that you did not successfully complete the culminating activity, then the key questions in the lessons must be completed, and you can retake the culminating activity. Students are permitted several attempts, so it doesn't hurt to try the culminating activity, because you can try if you are not successful the first time. If you're still not sure about trying the culminating instead of the key questions, ask us for a sample test so that you can see what the format looks like. So for PLAR Science, History, Geography, you can ask me for them, or PLAR English and Math, you can ask for Bonnie. So those of you who have chosen to complete the lessons and key questions, make sure you have the 5 lessons. Now, if you have lesson 1 and lesson 2 from last year's versions or previous versions, that's fine. Do not start over again using the 24-25 school year lessons. Continue from where you left off. Okay, so there are 5 there. So lessons 1 to 5 for PLAR Science. Oops, this is on the wrong spot here. It should be up here. So when we talked about the YouTube classes, so for those of you who don't have access to internet or Wi-Fi, you can still request the USB of classes. We will download the classes that you need and put it on a flash drive for you. So once you receive it, it will show the subject. So for example, PLAR Science, it will show you the lesson. So example, lesson 3. Then it shows you the key questions that's in that class. So you just click, open the lesson, you can listen or view the classes. Here's the mark sheet for students. If you have chosen to complete the lessons, you can see that there are 80 key questions. We have completed key questions 1 to 26 for lesson 1, which is astronomy. We also completed lesson 2 for biology, so key questions 27 to 40. And today we are starting with lesson 3. So we're getting there. We're into the halfway mark of the lessons. If you have decided to challenge PLAR Science and you have chosen to complete the culminating activity, here is the mark sheet for that. So it will still give you the 5 topics. So astronomy, biology, chemistry, physics, and environmental science, not in that order. And then you just read the information about each section, answer the questions following each section, send it to me, and then I will mark it and let you know if you have been successful. Okay, let's look at the cover page for PLAR Science, Lesson 3. So it will tell you the subject, this case chemistry. As I've mentioned, all the numbers that you need are on the first page or the cover page. It gives you the WASA studio number, shows you our radio channel 91.9 FM. If you have Bell Express View, it's channel 972. Gives you my Zoom link. If you have to download Zoom, you can see that my meeting ID and my passcode is there because you will need that. The office number, the fax number, my email, my Facebook. You can also check out Google Classroom. Remember, the code is different if you're using the NNEC Schools account or if you're using your personal Gmail account. So the codes are different for accessing Google Classroom. And if you can't get in there, just let me know and I will be more than happy to help you. Okay, so here are the key questions for Lesson 3. This is a bit more detailed. It tells you the lesson, provides you the topics, key question number, and the total marks for each key question. There are support questions in the lesson. Remember, the support questions are for practice, and you can find the answers at the end of this lesson. So on page 3 for chemistry, we will look at the particle theory. Page 4, states of matter. Page 5, change of state. Page 7, classification of matter. And we probably will get to, hopefully, as far as page 9, where we look at pure substances and mixtures. So turn to page 3. Now on page 3 it shows you the learning goals. So I can explain the statements of the particle model, and I can understand how matter is classified into pure substances and mixtures. Okay, so page 3, let's look at the introduction for chemistry. Well, chemistry is the study of chemicals and their reactions. So chemicals are the foundation of everything that's around us, including all life. If you think about it, chemistry is a bit like cooking because different ingredients are combined in creative ways to produce the final product. But as all cooks know, you can't cook properly until you know your ingredients and how your ingredients react with each other. So if you're, for example, if you're making a cake and maybe you forget to put an egg in there, or if you forget to put salt. So some of these ingredients, if you're missing them, it will have a reaction to your final, it will affect your final product. All food and medicines are also chemicals, or have chemicals, as are your clothes. In fact, it's hard to name something in your life that's not a chemical. So if you look at the meaning of chemistry, it's the study of composition, which is the amount of chemical in any chemical product. Also structure, meaning the arrangement of chemicals in a substance. Properties, which is behavior of chemical. And interaction, the reaction between substances with another substance. Okay, you might have mixed vinegar with baking soda and you can see that it fizzes. Twizzlers, bubblegum, gummy bears, what do they all have in common? We know that they're all types of candy, but they also contain chemicals in their ingredients. Even the preservatives in candy are chemicals. So again, chemicals are an important part of many things we use in our daily lives. So it's important we know what they are. Still on page 3, look at the heading, particle theory. So a theory is just an idea that helps us to explain the world around us. Sometimes you might hear people say, I have a theory. That means they have an idea to explain something. So in science, models are used to explain how things work. So the model used to explain matter is called the particle model. The particle model is based on 5 main ideas. So you can see on page 3, it shows you a list. So 1, 2, 3, 4, 5. We're going to look at each one closely. The first one says that all matter is made up of tiny particles. So this just means that everything around us, whether it's a solid, liquid, or gas, is made up of very, very small pieces called particles. These are too tiny to see with the naked eye, meaning that you have to use a special kind of device so that you could see the tiny particles. So here's an example. Here's a piece of chalk. And you can see it's a solid, but inside that chalk are these tiny particles that makes up that chalk. Okay, so that's the first one. All matter is made up of tiny particles. Okay, the second particle model is that all particles of one substance are the same. This means that all the particles in a particular material, like water or metal, are identical to each other. Here's an example. Every water molecule is made up of the same types of atoms, and each one is the same as the others. Okay, number 3. Different substances are made of different particles, meaning that the particles in different materials are not the same. For example, the particles in water are different from the particles in salt, and the particles in air are different from those in oil. So each substance has its own unique type of particle. So different substances are made of different particles. Okay, the fourth one is that the particles are always moving. The more energy the particles have, the faster they move. Particles are always in motion. When they have more energy, like when they're heated, they move faster. So you can tell the difference here. This one is cold. You can see the temperature. So those particles are moving slowly. And as it's getting warmer, you can see that the particles are moving faster. And this one, it's at 40 degrees. So these are all in Celsius. It's hot. Notice that these particles are moving faster. They're bouncing off each other. This one looks like it's -5 degrees. And this one looks like it's 20 degrees. So here's an example of someone with a peanut allergy. So when thinking about particles in motion, remember that the proteins from peanuts can move and spread through the air as tiny particles or be transferred by contact. That's why people with severe allergies need to avoid even a small traces of peanuts, because the faster particles move, like when heated or airborne, the easier they can spread. Okay, finally we have the last one. There are attractive forces between particles. That means that particles are pulled toward each other by invisible forces like magnets. These attractive forces keep particles close together, like in solids. Notice in solids the attraction is very strong. Or let them move around but stay connected, like in liquids. So here's liquid, and look at gas. So the attractive forces for gases, the attraction is weak. For liquids, it's strong. For solids, it's very strong. Okay, on the bottom of page 3, in a pure substance, all the particles are the same. So for example, pure water has only water particles. Pure gold has only gold particles. This is what makes it pure. On the picture you can see that's gold. It's an element and it's made up of only gold atoms. However, you see the picture, someone wearing a gold necklace or gold jewelry. That is not pure because other elements are added to it to make it harder so that it wears better. Okay, so that's the difference between a pure substance, and now we look at a mixture. So a mixture has at least 2 different types of particles, meaning that each type of particle comes from a pure substance. So when you have a mixture, you have something that's made up of 2 or more pure substances combined. One example is a pizza. It's a mixture because it's made up of different things. Each ingredient, like the cheese, pepperoni, or mushrooms, is a pure substance on its own. You could list all the ingredients separately as pure substances. Another example is gravel. Gravel is a mixture of different types and sizes of rocks. You can easily see the different particles. Notice you can sort the different types and sizes of rocks in gravel. Okay, so those are mixture. So in summary, what we're looking at, what are particles made of? Well, when scientists studied different types of matter, they divided particles into 2 groups. Okay, one group are elements and the others compounds. So later, they discovered that elements and compounds are made of even smaller particles, or subgroups called atoms and molecules. Okay, now let's look at states of matter. So states of matter is on page 4. So matter exists in 3 states. So you could find matter could be solid, it could be liquid, or it could be gas. Now water can be in all 3 forms. Normally it's a liquid, but if you freeze it, when it turns into ice, it becomes a solid. If you boil it, it turns into gas, which is steam. Okay, so that's the 3 states. Looking at solids, we notice that they have a definite shape and a definite volume. That means all particles are very close together. An example is a chair. So if you look around where you are, what are some things that you can see that are examples of solids? So it could be your coffee mug, could be the computer, could be the chair, could be the ruler, and so on. Liquids, on the other hand, have an indefinite shape, but they have a definite volume. That means the particles are not very close together. So indefinite shape, if you put water in a glass, in that shape, it takes the shape of the particular glass that you put it in. If you put it in a skinnier glass or a tall glass, it will take that shape, but it has a definite volume. So depending on how much water is in that glass, it could be 500 ml, looks like that, and then 500 ml also looks like this. Gases have an indefinite shape and indefinite volume because particles of gases are very far apart and they move freely. Okay, just like the steam that's coming off the boiling pot. Okay, that's a gas. Okay, let's try key questions 41 to 43 of your lesson book. So again, on the cover page, you have everything that you need to do your key questions. So for example, if you want to contact me or find out where to send your work, it's there. Again, you have the option to complete the key questions from the lessons or choose to take the culminating activity. So here's the list of the key questions for lesson 3. You might get halfway doing lesson 3 and decide that you would rather do the culminating. Because maybe you thought that you didn't want to take the culminating activity because you're not sure about chemistry, and then once you looked at it, you might say, maybe I can do this. So go ahead and ask for the culminating activity. Okay, so the first key question is key question 41. Remember, answer the following questions in complete sentences for full marks. You can use the spaces that I have provided. You can also use additional line paper if you need, or you can also use your laptop to answer the questions. So the first one, key question 41, is what is chemistry? So that is a straightforward question. It's a hand question because you can find the answer in your book. So if you turn to lesson 3, right at the beginning, it tells you what chemistry is. So chemistry is, or chemistry means, then write your response. Key question 42, we just finished looking at that. What are the 3 states of matter? So instead of just naming them out, you can still write it out in a complete sentence. 3 states, or the 3 states of matter, and then write them out. Key question 43, list the statements. Now this is very important because I've seen statements written in here, but it has nothing to do with the particle theory. People write down melting, freezing, and evaporation. That's on page 5. It says the particle theory explains the changes of state, but that's not what the particle theory is. We're looking for the statements that make up the particle model. So if you're not sure, I'll do the first one for you. The first one is that all matter is made up of tiny particles. That's the first statement. Okay, so that's the first. So you need to name the second, the third, the fourth, and the fifth. There are 5 statements that make up the particle model. Okay, before we can do key question 44, we need to continue with continue on page 5, change of state. So if you're following along, we're on page 5. Change of state. So a change of state involves the addition, that means you're adding, or removal, which means you're taking out, of heat energy. So substances can change state in 5 ways. First one is melting. That means a solid changes to a liquid when heated. 2, vaporization. A liquid changes to a gas when heated. Notice this addition or removal of heat energy. 3, condensation. That's when a gas changes to a liquid when cooled. 4, freezing. A liquid changes to a solid when cooled. And 5, sublimation, which is a solid becomes a gas when heated, or a gas becomes a solid when cooled, and it bypasses or without passing through the liquid state. We're going to look at these closely. So individually, the first one is melting. Again, that happens when a solid is heated and turns into a liquid. So if your kids made a snowman and then the next day it happens to be warm, you will notice that your kid's snowman is starting to melt. Same thing with ice. You take some ice cubes and you leave it on the counter. Your house is warm. You will notice that it will melt and you'll get water pooling on your counter. So matters can change its state when it's cooled or heated. So when a matter is heated, its particles absorb heat energy, and that means they vibrate or they move faster, just like we have seen earlier. So because they're bouncing off each other, okay, and then it expands and then it melts. Okay, the second one, vaporization. This happens when a liquid is heated and turns into a gas. So particles near the surface may collide and be bumped out of the liquid. Evaporation occurs faster if a liquid is heated. So you can see here, that's boiling. So boiling water, the molecules speed up, they move farther apart, and they absorb heat energy. When a liquid reaches its boiling point, so the boiling point is 100 degrees Celsius, many gas particles escape at one time in the form of large bubbles. So here you can see liquid, and then when it's boiled, so there's the boiling point, now it becomes gas. Okay, so vaporization, think of boiling. Okay, number 3 is condensation. So condensation just means is when a gas turns into a liquid after touching a cooler surface. This change is important in the water cycle, and this is the opposite of evaporation. So for condensation to happen, the air needs to be full of moisture. And there must be a surface for the gas to turn into a liquid. So just like when you see dew on the grass, or water vapor condenses into a liquid after making contact with the surface of a cold bottle. During condensation, the particles slow down and heat energy is released, causing the gas to change into a liquid. So you can see here you have a cold glass, then you have warm air, and then the condensation you see on the outside of the glass. Okay, that's the surface that's needed. So So that's important, that it needs to have a surface for the gas to turn into liquid. So a cold glass, on a hot day, you will get condensation. Okay, number 4 is freezing. Okay, that's been happening lately. We've been getting freezing rain. Freezing is when a liquid turns into a solid as heat is removed. So as the liquid cools, the particles move slower. This causes fewer collisions and making the particles take up less space. When the liquid reaches its freezing point, so if you look at the temperature on the right hand side, water freezes at, and most of us look at this when we're checking the weather, water freezes at 0 degrees Celsius. So once it's 0 degree, then you know you are at the freezing point where you have a liquid becoming a solid. So if it's raining, and all of a sudden the temperature goes down to 0, you know that you will get freezing rain. So you can see up the top, it shows water. And then once it freezes, you can see that water is a liquid, and once it freezes, it becomes a solid because it becomes to ice. Okay, and the last one is sublimation. This is when you have a solid turn directly into gas when heated, or a gas can change directly into solid when cooled without becoming a liquid first. That's the process called sublimation. An example of sublimation is dry ice, which is a solid carbon dioxide. When dry ice is heated, it changes directly from a solid to gas. Okay, it doesn't turn into a liquid first, it just goes from solid to a gas. Okay, so what have we looked at? We said that starting off with matter, which is anything that takes up space, is usually found in mixtures, which can be sorted into substances, which are usually compounds, which can then be broken down into elements, which cannot be broken down. So you might want to start from the bottom. All matter comes from elements, which can then be compounds, which are substances, which can either be mixtures, and so on. Okay, turn to page 6. So on page 6, you'll see that you will see that graphic or picture, and then on page 7, you can see the heading, classification of matter. So I'm following your book, your lesson book, page by page here. So classification of matter, so to classify something means to organize it into different groups or categories. So for example, think about organizing your clothes in a drawer. So instead of just throwing everything in, you might sort them into groups. You might put your socks together, your underwear in another section, your shirts in one place, and pants in another. You might even organize them by color. And you can probably think of other ways you organize things at home. So for example, if you're organizing your kitchen cupboards, you will put your plates either by size, so you might put the bigger plates together, the smaller plates in another section. This one looks like they're organized, the plates are organized by color or pattern. Then you have glasses, cups, bowls, and so on. So in the same way, matter can be classified. So everything that's around us can also be sorted. All substances are made up of tiny particles called atoms. So all matter can be placed in two categories. We said that before. They can either be pure substances or they can be mixtures. You can see here. So notice the word atom. It's in blue. This is all substances are made up of tiny particles called atoms. So from the stars and the sun to your body to the clothes you wear and the food you eat, everything is made of atoms. Okay. There are two types of pure substances. So we just said matter can be sorted or classified into pure substances and then can be sub-classified or organized into elements or compounds. So we're going to look at that first. So substances that are made up of only one type of atom are called elements. For example, if a substance is made only of carbon atoms, then the element is carbon. If the substance has two oxygen atoms stuck together, it's called oxygen molecule because there's two. So like that. But it's still considered an element because it only contains one type of atom. Both elements and compounds are types of pure substances. So this is what you need to underline in your book. A pure substance contains only one type of atom or molecule, and its properties are always the same no matter where it's found. Okay, so an element is a pure substance, like we said, made of only one type of atom. Elements are what we call the basic building blocks for all matter. That's what we have to start with. Some examples of elements are iron, oxygen, hydrogen, gold, and helium. Okay, so underline that. A pure substance is a substance made up of only one type of atom or molecule. Okay, up next, we can take the atoms and join them together to form more complex particles, like we said, called molecules. So it's still one type of atom, but we can bond them or stick them together so that they are made up of one type of molecule. Now that molecule has at least two different types of atoms. When that happens, it's now called a compound. So if you take two elements together, for example, hydrogen and oxygen, then you can make up a water compound. Okay, so 2 parts hydrogen, 1 part oxygen. So that's why it's called H2O. You're combining 2 atoms, okay, to form a compound. So the number of atoms in a molecule can range from just 2 to thousands depending on the type of compound it is. There are just over 100 types of atoms, but there are millions of different substances. Just like when you think about the alphabet, there's 26 letters in the alphabet, but when you combine them together, you can form words. So we just said there are just over 100 types of atoms, but there are millions of different substances. This is because substances are made up of different types of molecules. So molecules can have different types of atoms and also different amounts of each atom, just like what I showed you with the water molecule having 2 hydrogen atoms and 1 oxygen atom. So anytime 2 atoms join together or bonded, they make a molecule. When we look at water as a compound, we now see that water always has twice as many hydrogen atoms as oxygen atoms. Okay, it's fixed. That's the recipe for water. It has to have 2 parts hydrogen, 1 part oxygen. Okay, next up is mixture. So a substance whose properties are not consistent or vary is called an impure substance. Here's an example. Sand has different types of particles. It might have white ones, dark ones. Sometimes you get pieces of soil in it. Because sand contains more than one type of particle, we call it a mixture. So a mixture is made when 2 or more different types of particles are combined in the same substance. So again, we're starting with matter here. We just talked about pure substances where you have elements and compounds. Now we're looking at mixtures. So again, mixture is made up of 2 or more pure substances. Think of the pizza that we looked at. All the toppings are made up of pure substances. You have the cheese, you have the pepperoni, you have onions, depending on what you like on the topping, but it's a mixture of stuff made of pure substances. So in a mixture, the particles share the same space, but they do not combine to form new particles. Look at the sulfur and iron fillings when they are mixed together. They don't create a new substance. They stay as sulfur and iron fillings, and you can also separate them from each other. Notice here a magnet attracts the iron particles, but it doesn't attract the sulfur. So the sulfur is that white powder, and you can see the iron fillings. That's the black stuff. And because it has iron particles, the magnet attracts it. So you can actually separate it. Okay, another example of a mixture is pop or soda, whichever you want to call it. It contains liquid water, dissolved sugar, which is a solid, and carbon dioxide, which is a gas. So mixtures can be classified into 2 types. So mixtures are either homogeneous mixture, where it looks like there's only one substance or phase. Examples include tea, coffee, juice, or pop, where you can't easily see the separate parts. The other one is heterogeneous mixtures. These ones, you can see the different substances, like what we just looked at. You had the mixture of sulfur and iron fillings. Okay, so now looking at the classification of matter, now you have a mixture, and you have 2 types of mixtures. One is heterogeneous mixture, and the other one is homogeneous mixture. Okay, so we're going to stop here. When we come back on Wednesday, we are going to continue with the classification of matter, and again looking more closely at heterogeneous and homogeneous mixtures. And when we come back on Wednesday, make sure that you have completed key questions 41, which is about chemistry, 42, 3 states of matter, and number 3, the particle model. Okay, so that's it for today. I will talk to you again on Wednesday. Miigwech.
Recording stopped.